So we've got an acoustically transparent woven material for the screen, which is sitting about 70 mil off the speaker face for the front speakers here, the LCRs. This is Elementi audio, so Elementi audio is defined by the fact that we have amplifiers for each of the speakers that are matched, so they're a digital active speaker system. So there's amplifiers driving the tweeters and amplifiers driving the bass section of the individual speakers, and those profiles with high-level DSP is located at the front of the cinema room here. So we've wired in balanced cabling from the audio processor to the amplifiers, so that we're maintaining the integrity of the audio signal, and then very short speaker cable runs to the speakers. So this is a philosophy for Elementi that we use in all of our projects, which just maintains the quality of the audio signal and gives us the best chance of delivering good quality audio to our clients. Now, another unique sort of feature of this room is, so obviously we've got subwoofers at the front of the room, and this room, although it's a high quality room in a lot of respects, it is a little bit limited on budget. So we had to maintain a certain level with the budget of the room that we couldn't go beyond. So there's two subwoofers in the room, one at the front and one at the back, that are designed to balance out the standing waves as best we can in the room. Being a small room, it's not a big audio system. So obviously there's three speakers behind the screen, so left, center, right. There's our subwoofers. So in this room, there's two subwoofers, one at the front, one at the back, which are designed to cancel out standing waves in the room. And then out the rest of the room, we've got speakers on the sidewalls and a set of speakers in the rear. So that's 7 speakers in the horizontal plane. There's 4 Atmos channels. There's only 2 rows of seating, so 4 Atmos channels is all that's really required to get good coverage across the seats. And being the Elementi Air speaker system, the thing that defines that audio system is that it's got incredibly wide horizontal dispersion. So even though there's not a huge amount of speakers in this room, the coverage in this room is really excellent. There is no holes in the audio system here in terms of the coverage. In fact, front wides, where you would typically put front wide speakers onto the sidewalls, in my opinion, it's completely unnecessary in a room like this, where the dispersion is so wide that there really isn't a gap as you're panning from the front to the side speakers. There's no gap to be filled in the audio, so the front wides are not necessary. This is a heritage listed home, and we didn't have space to put the air conditioning fan coil outside the cinema room. Everything had to be contained within the room, but sound isolation was critical. So this is a lightweight structure above us, and there's a bedroom above this cinema room. It's the main bedroom for the house. So sound isolation was critical in that direction. So we've created a sound isolated shell and isolated that. Then we've put the air conditioning system down below that sound isolated shell. Then we've built a whole nother ceiling structure below the air conditioning system, and then incorporated this bulkhead below that ceiling. So that sound doesn't transfer from inside the cinema to the layer where the AC system is, there's attenuators for the air conditioning system. So where the air goes through the grill, so there's a return air grill up in that back corner of the cinema ceiling. When air goes through that grill, the sound can't transfer through that grill and escape into the rest of the structure. There's an attenuator, so attenuator means it's attenuating the audio signal or the sound pressure level down to a lower level, so that when it goes into the next space, it's not causing problems up there. So the system is way more complex than people think it is. We've got supply air ducts and registers in the steps here, so that's blowing the air out towards the front of the room. And then the return air is up high on the ceiling in the back corner, so that's sort of dragging the air back through into the other end of the cinema room, so you're getting a nice natural flow and very even temperature. We design all of our cinemas to operate on a low fan speed. It's what I would call a low static system. So air conditioning systems typically are designed to maintain a higher velocity of air and to create the distribution through the room based on that higher velocity. We design what's called low static systems, where we're creating positive and negative pressure in the room, and it's not just the air being forced out of the ducts into the room, but also the negative pressure being created by the return air, bringing the air back into the system and pulling the air out of the supply air ducts and out of the vents. So by doing that, you get a very, very quiet air conditioning system that's also very even in temperature throughout the entire room. And you can only do that as a design if you are controlling the pressure of the entire system. So AC design is actually a lot more complex than people tend to think it is, and it's why we are heavily involved in the air conditioning design of all of our cinema rooms. We've got a Sony projector here, which, like all projectors, is generating light. And generating light, they also generate heat. So we need to be able to ventilate the projector. Now, because we're introducing fresh air into the air conditioning system, we also need to be able to release pressure from the room. And so there's a duct off the back of the hush box, which is taking the heat from the projector and venting it back into the ceiling space, once again through attenuators, and then out through the heritage vent at the front of the house. This is part and parcel of what we would do in any cinema room. And the reason why you would do it is if the projector's not struggling to get rid of heat, then it will run much more quietly and not be audible in the room. So this hush box that we've created here is lined with insulation on all sides. So when the projector's running, it's much quieter than the projector would normally be in a room like this. Sound isolation was a significant part of the cinema design. The main bedroom for the house is directly above us, and outside this door is the main living area for the entire house. So they needed to be able to sit in the cinema room and for this cinema room not to impact the rest of the house. So from a sound isolation point of view, we do have masonry in the walls, which is fantastic. Masonry adds mass, and that's great for stopping bass. But what's not good for stopping bass is when you have elements inside the cinema connected to that masonry. Sound will travel much more easily through structure than it will through air. So if anyone's lived in an apartment block and somebody's drilled a hole in a garage, you can hear that drill through the entire unit complex. That's an example of structural transmission. So part of the sound isolation system in this room is isolating the inside of the room from the outside of the room. So there's resilient mounted mounts in the wall. We've also used a compound called green glue to help to take out the resonance of the wall, and which also helps with standing waves in the room. So all of this structure actually helps to mitigate standing waves by reducing some of the peaks and some of the depth of the nulls in the room by creating attenuation in the walls for those frequencies. And then a big part of that system, because we've got a door in the cinema room, so technically the door would be a weak point, we've got an airlock design. So this is the inside of the cinema, and we've got a special door designed to reduce the first reflection strength from the front speakers. And what this improves is the voice intelligibility of the system. So a crucial element for any door that's going to cop a strong reflection off one of the front speakers. And then if we open up that door, there's a big air gap between this door and the next door. This is a special sound isolation door manufactured by Wavetrain as part of our CinemaWorks range. And this size of this void is actually really what creates the sound isolation. So this system has been designed to attenuate 70 dB of audio, whereas if I was just using a specially designed sound isolation door, the maximum I could ever get to would be about 45 dB. No matter how big I made the door, I just wouldn't improve much beyond that. So it's the airlock that actually makes that work. And the other side of the airlock is, remember I was talking about the disconnect between the inside of the cinema and the outside of the cinema? Well, that also extends to the structure with the door here. So there's actually a break in the structure with a silicon sealed gap, and so there's nothing touching from the inside of the cinema structure to the outside of the cinema structure, so we don't get that transfer of vibration into the structure. And that holistic design is there to make sure that when they're in the cinema room, it's not being heard out in the living room, but also, more importantly, up in the main bedroom where it's very, very quiet at night. And if we're playing loud movies down here in the cinema, then basically they wouldn't be able to use the room down in the cinema room here when everyone was trying to sleep. So the AV equipment is located outside the cinema. We've run balance cabling from this audio processor into the cinema room for the amplifiers that are mounted inside the cinema room. So we've designed the cabinetry to match in with the walls. We've got a rack in here which slides out, and you can see all of the cabling that's been sort of loomed up inside the rack area, so it's nice and neat, so we can pull it all out, we can service it. All of the cabling here is nicely labelled and fairly neat and segregated. It just means that the system is easier to service over time if there's any issues or if they want to add components, and there have been some additional components added to this cinema room already. And then the other components in here are the subboard for the electrical. We always have our own subboard for the cinema room, which creates a demarcation between the rest of the home and what is the cinema and our contract. And then in behind this board here is the lighting, dimmers, relays to control the cinema room. And then because heat is a big issue with any rack, there's a vent at the top of the cupboard here, which has got mechanical ventilation in it, so it's pulling the air out. And there's a gap underneath the door here of about 20 mil, so there's space to pull the air under the door through the rack, and then to exhaust that heat out the top, so the equipment just remains nice and cool. And the benefit for that isn't just the equipment falling over in terms of it potentially not working. If you run your equipment hot, then you're going to have issues long term. Heat in the electrical components is going to lead to dry solder joints. It's going to lead to servicing issues, and your equipment's going to last potentially half as long as what it would have if the rack had been correctly designed in terms of heat dissipation.